All right, 7.5, last section of chapter 7. So first we're going to put these shapes on the graph and then show that it is a trapezoid. And then decide if it's isosceles. Remember, isosceles means the legs are equal. So negative 3, 3. Negative 1, 1. 1, negative 4. And negative 3, 0. Okay, so clearly this leg, even though we don't make assumptions, clearly this leg and this leg are not the same length. So it's not isosceles, but we do need to prove that, let's see, DE is parallel to FG. So all we have to do is count. So from D, if we count down 1, down 2, right 2, so the slope of DE is down 2, right 2, which is negative 1. And from G to F, we count down 1, 2, 3, 4, right 1, 2, 3, 4. So the slope of GF is down 4, right 4, which is also negative 1. Okay, that means it is a trapezoid, but not isosceles. All right, next one, negative 2, 0. Kind of overlapping a little bit here. So it's going to be M. And N, 0, 4. P at 5, 4. And Q at 8, 0. Okay. So without counting, you can see that the slope of NP and OQ are both 0. They're both horizontal lines. So we have trapezoid right there. Now we have to do the distance of MN and, I'm sorry, that's PQ, not OQ. Okay, so remember the distance formula. So the distance of MN would be square root of negative 2 minus 0 squared plus 0 minus 4 squared. And that ends up being the square root of 4 plus 16, which is the square root of 20. And then the distance for PQ would be 5 minus 8 squared plus 4 minus 0 squared. So that ends up being 9 plus 16, which is the square root of 25, which is 5, but not equal. Even though they look close to equal, they're not. Okay, so PQ is a little bit longer than MN. So again, we have, it is a trap, but it's not isosceles. Okay, so that's why we go off, on the previous one, we could clearly see DG, DE, and GF were not equal, but These two were close, so you do the formula to prove it. All right, number 7 and 8. Find the measure of each angle in the isosceles trapezoid. Okay, so in the isosceles trapezoids, remember the base angles are equal. So this is also 118. All right, and then consecutive angles are supplementary. So 180 minus 118 is 62 and 62. All right, same thing here, 82 and 82. And then 180 minus 82 would be 98 and 98. Good facts to have on your reference cards. Right, length of the midsegment. Remember, the length of the midsegment is the average of these two numbers. So you just take 18 plus 10 and divide it by 2. So that's 28 divided by 2. That makes MN 14. Same thing here. 57 plus 76 divided by 2. And that's actually going to give us a decimal of 66.5. And that's okay. Now, going the other direction, doing a little algebra here. Again, this and this average to this. So this plus this divided by 2 equals this. Same procedure as this, it's just we're swapping the x with one of the sides, one of the bases. So you start off by multiplying by 2, and that leaves the 10 plus x. It is not 20 plus 2x. The 2 cancels, that's why we did it. Equals 14, subtract 10, x equals 4. Same thing here, 11.5 plus an unknown divided by 2 will give us 18.7. We start by getting rid of the 2. That's 11.5 plus x equals 18.7 times 2, which is 37.4. And then we just subtract the 11.5, x equals 25.9. Right, 13 and 14. It's going to be kind of messy because we're going to be overlapping here. So find the length of the midsegment of the trapezoid with a given vertices. So 2, 0, right there. 8, negative 4, right here. 12, 2. That's off a little bit, so sorry about that. And 0, 10, right there. Okay, so we have A, B, C, D. So try to find the length of the midsegment of the trapezoid. So what we need to do is find the length of DC and AB. And then we're going to average them. So AB, the distance is going to be 2 minus 8 squared plus 12 minus, sorry, I'm going over the wrong one. 2 minus 8 and 0, careful, minus negative 4 squared. That becomes plus. 2 minus 8 is negative 6, but squared is 36. 4 squared is 16, so this is the square root of 52. And if we just put that in the calculator, the square root of 52 is about 7.2. Okay. And then DC, do that up here, is going to be 12 minus 0 squared, that's going to be 144, plus 2 minus 10 squared, so that's going to be negative 8 squared is positive 64. So positive 64 plus 144 is 208. So we take the square root of 208, and we get 14.4. So for 13, we're going to take 7.2 plus 14.4 and divide it by 2. And get 10.8 for the mid segment, which would be approximately, something like that. Okay? Now on to 14. So for 14, we're going to do the same thing. So we're going to do negative 2, 4. Right there. Negative 2, negative 4. Right there. So that's S and T. And then 3, negative 2. And V at 1310. All right. So we're trying to see what the length of SV and TU are. So SV is going to be this one and this one. So be careful with that you're not doing ST. So we're going to do negative 2 minus 13 squared plus 4 minus 10 squared. All right, that ends up being the square root of 261, which is 16.2. And then we're going to do TU. So negative 2, again, minus 3 this time, squared, plus negative 4 minus negative 2. Careful with that one. That's going to become a plus. All right? And that ends up being the square root of 29. And the square root of 29 is 5.4, rounded. So we're going to do 14 right here. 16.2 plus 5.4 divided by 2. Ends up being so if we add 16.2 plus 5.4 and divide by 2, we get 10.8 again. So they both have a mid-segment of 10.8. Number 15. Okay, so again, there's 360 degrees in a quadrilateral. We have 100 here and 40 here, all right? That's 140, so 360 minus 140 leaves 220. These two angles are going to match up, so if you divide this by 2, each angle is 110 degrees. All right, same idea here. We have 90 here. 90 plus 150 is 240. So 360 minus 240. $120. And if we divide that, E and G are both 60 degrees. Okay. Now this one, remember, this is going to match over here. So this is 110. So we're going to add those three up. 110 plus 110 is 220. Okay. 220 plus 60 is 280. So 360 minus 280 leaves us with 80. So G is 80 degrees. And on 18, same idea. If this is 90, that's 90. So 110 plus 90 is 200, plus another 90 is 290. If we subtract that from 360, we get 70. So angle G is 70 degrees. Give the most specific name for the quadrilateral. Explain your reasoning. Okay, well, 21 is a quadrilateral. It's a parallelogram, but it is a rectangle. And it has all right angles. Okay, if it was all equal sides, also it would be a square, but rectangle is the most specific name we have here. 22 is a trapezoid. We have two parallel sides. 23 is a rhombus because all four sides, but with this 90 degrees here, that means all four are 90 because they're opposite, all equal angles, or equal sides, so it's also equiangular. So it is a square. It has congruent sides and 90-degree angles. And 24, we have this situation here where those two are the same and these two are the same. We have a kite. We have two pair of consecutive sides are congruent. So these two are consecutive and those two are consecutive. Last but not least, we've already done this before with simpler problems. So remember, this plus this divided by 2 gives us this. So 3x plus 1 plus 15 divided by 2 equals 12.5. So again, I'm going to start out by getting rid of that 2, which gives me 3x plus 16 equals 25. Subtract 16, and I get 9. Divide by 3, x is 3. Same idea here. Whoops. The 3x plus 2 plus the 2x minus 2, all divided by 2 equals 15. Same start. Multiply by 2 to cancel that 2. Over here, 3x plus 2x is 5x. The 2's cancel, 2 minus 2, and that gives me 30. Divide by 5, x is 6,